Alright guys, so here's a new little tutorial session. We posted online for you guys to ask questions, so I just went and I got all the questions that were posted by this evening, and I'm just going to go over a few of the answers. So looks like a few people wanted me to do number 1 part B. So here's 1B. Describe the end behavior of each function and state the equation of the horizontal asymptote, if any. Alright, well the end behavior, well it kind of depends on the way you do it. For me, the end behavior, well I like to do the actual division, 2x divided by x squared plus 4, and whatever your answer is up here is going to be what your asymptote. But if you look, this is just going to be 0. X squared doesn't go into 2x. So the end behavior is just y equals 0. The easiest way to do that, though, guys, is you should know that if you have degree 1 on top, degree 1 on top, and degree 2 on the bottom, then you're definitely going to have an asymptote of y equals 0. Okay, so describe the end behavior of each function and state the equation of the horizontal asymptote, if any. So the end behavior is as x approaches infinity, y approaches 0. Now I'm going to still have to say from the top or the bottom, but as x approaches negative infinity, y approaches 0. Okay, and the horizontal asymptote at y equals 0. Now, there is one more thing. I'm going to plug in a really big number here. So let's plug in g of 100 equals 200 over a big number. That's a positive number. Okay, so I know that this is going to approach from the top. This is a positive, so it's going to be 0 plus a little tiny bit. And so it's going to be a little bit bigger than 0. So over here I'm going to put, it's coming from the top on the right hand side. And let's plug in a negative number, negative big number, negative 100. So you're going to get on the top, you're going to get negative 200. And on the bottom you're going to get a positive number because x squared is still going to be positive. So positive number. This is going to be a negative, and so you're going to be a little bit less than 0. Over here we're approaching 0 from the bottom. Right? I'm just going to do a quick sketch of the graph just so that you can watch me do. It's just one extra chance for you guys to watch me sketch graphs, I guess. The top, it looks like it's going to have a 0 right at 0. When x is 0, the top is going to be 0, so I know 0, 0 is a point. There is no asymptote because there's no time that x squared plus 4 ever equals 0. Right? You can never have x squared equals negative 4. That doesn't make any sense. Right? So, and we know it comes like this. It approaches 0 from the top on the right and approaches from the bottom on the left. So it must just do something like this. There you go. There's my graph. There's nothing else really for it to do. We know that it has no asymptotes. It has no zeros, so it just has to kind of go upward and then come back down. Right, let's go to the next question. Under what conditions, this is number 3, under what conditions does a rational function have an oblique asymptote? Oblique asymptote, well, that is just straight up 3a. Oblique asymptote is when the degree in the numerator is 1 more than the degree in the denominator. Okay, that's because when you do the division, if you have like an x to the 5 term, and here you have an x to the 4 term, then when you divide it, you're going to end up with just an x term here. right? So you're going to end up with a linear term when you do the division, and so if it's linear, then you know it's going to be, the asymptote is going to be a straight line, something like that, or maybe something straight down like that. Alright, so this is your answer right here. Okay, part B. Explain how to determine the equation of the oblique asymptote of a rational function that satisfies conditions in part A. Oh, and I guess I kind of just explained that. We divide the numerator by the denominator the quotient is our oblique asymptote. Well, the quotient is your asymptote no matter what kind of rational function you have. But in this case it's going to be oblique because that's what the question's asking about. So just in case you guys haven't seen the videos I posted today, sorry it took me so long. I was having so many technical issues. I wanted to rip my hair out. I've been working since like midnight last night. I didn't even go to bed, so I was working really hard on that. Okay, so I'm going to do a new video, by the way. So if you are still wondering about asymptotes, oblique asymptotes, horizontal asymptotes, any type of end behavior to the right and to the left, just please watch those videos and let me know if there's anything you need me to add, if you have any questions on them, and I will add to it. Okay, so I'm going to end this video for now so it's not too long, and I'll continue with number 5. And I'm going to do 5, 6, 7, 8, 9, 11, and number 2 from the assessment part. I'll post all those different videos. Okay, see you guys soon.